All right, so this is a second lesson. Pythagorean theory. Okay, let's type part 2. All right, this is so we're going to discuss several problems and how to apply the Pythagorean theories to solve those problems. Okay, it's pretty challenging. Some problems are pretty challenging. Okay? And then I hope you can learn some ideas how to do this type of problems. Okay, the first problem I want to discuss is if you have a right triangle, okay, and we are given the information the perimeter is going to be 220, area is going to be 990. Okay, can we find the length of the longest one of the hypotenuse? Okay, so let me give you some ideas first. Because the right triangle, actually you're given 3 equations. If this side is A, this side is C. First condition, yeah, parameter, you write down A plus B plus C equals 220. Second condition, A times B equals, right, 1/2 of the A times equals 990. Actually, there'll be 3 equations because by the Pythagorean theory, A squared plus B squared equals C squared. So using this, can you find the C? Okay, that's my hint. You can try, okay? I'll give you 1 minute. I hope you're able to find it. This is a solving system of linear equations. Okay. So you actually convert it to an algebraic problem. Just solve 3 system of 3 equations. They're all different equations. The first equation is linear equation, A plus B plus C equals 20, right? 220. Okay. The second equation is A times B, right? It's a product. Okay. So then third equation is square. A squared, quadratic equation. So how can we do this? Okay, you have to find the equation in C only. You can find A and B and the C, all of it. Okay, but then we just need to find the C. So let's take a look at the first equation we remember, right? So this is the equation we know. Let me enlarge the screen. Okay. Okay, so A squared plus, it's going to be A squared plus, 2AB, okay. Then you see that, okay, what you are given? Okay, this can be replaced by C squared. This can be replaced by 990 times 4, right? Because AB is going to be 990 times 2, okay? And how about the other side? A plus B, but we are given A plus B plus C. That's great. That's 220 minus C squared. So you get a equation in C only. So 220 squared minus 2 times 220 times C plus C squared, right? And then C squared is gone. So it turns out to be a linear equation. Okay, it's a linear equation. So I get right. Then I divide both sides by 2 times 220. Okay. I think what I'm trying to do is find an easy way to simplify it. I don't multiply this out because 99, 22, you know, just they're both a multiple of 11. Okay, so it's better to write it as you know, it's 2 times. So it's going to be 2 squared, 110 squared, right? Minus 9 times 110 times 4. Okay, here's a 4 times, 4 times 110. Okay, so then you will see that 4 will be canceled out, right? Okay, and also you cancel out 110. See? So then 100. Okay, that is how do we simplify. All right. Our next problem is you have a rectangle, okay? Okay, and this side is A, this side B. I'm not going to specify the side, okay? I'm trying to find the point P so that this distance equal to that distance equal to that distance, okay? Express X in terms of A and B, okay? Then you know, then you can get a general formula, right? It could be a square, could be a rectangle. You know, you can figure it out as X. Okay. Yeah. So the key point is to find the right triangle, express each side in terms of X and then B, but in the linear form. Then you apply the Pythagorean theory to find the X. Okay, to get the equation in X, then you solve for X. Okay, so please work on that. Okay, I'll give you 1 minute to think about. Right, so the idea is look for triangles, right? The right triangles. And by draw addition lines, and you can extend this line all the way to the bottom. So you do get two congruent right triangle. Okay. So once you get a right triangle, then you have to express each side in terms of those given numbers. So this side is X, right? How about the bottom side? This is a bit half of it, right? Because it's a middle point. Now, the other side, don't apply the Pythagorean theorem right now. The other side, you can express it in terms of x or b. Okay, that's it. You can draw this line here. So this is x, right? There's a whole line, so this will be b minus x. So b minus x, right? Now once you get that, then apply the Pythagorean theory. So b minus x squared plus a over 2 squared equals x squared. So let's solve this equation, and it's easy, right? Yeah, when you do the homework, you need to draw the picture, okay? And show all the details to get the answer. So this is a b squared minus 2bx plus x squared. Here's a squared over 4, that's x squared. So x squared is gone, and then you get another linear equation. So 2bx equals b squared plus a squared over 4, right? Then both sides divide by 2b. Okay, so that is the answer. Now you can simplify a little bit. If you simplify a little bit, it's called 4b squared plus a squared and 8b. So you get an expression. So whenever you get a value of a and b, the edge length of the rectangle, you can always find the x. Right? Yeah, sometimes you do have to do that if you want to make a hole, on a piece of board, and you want to make sure this hole, it's in the somewhere in the middle, because if you want to draw the circle, you want to make sure the circle touches the top page line and passes those two vertices. Okay, then you have to find the x, right? Once you find the x, from the middle point on the top line, and then you draw the vertical line, and then you can measure it, and then you find your point. Okay, so that's use, it's the use of mathematics. Right, another problem we want to do is, I have a rectangle. This is a rectangle, okay? Inside rectangle, I have a right triangle. Okay, this is right triangle, okay? And here's A, B, C, D. Okay. What I'm given here is, so BE equals A. EC equals B, okay? A and B, okay? And I want to find out AB, okay? Expressed in terms of little a and b. All right. So this is a right triangle, right? Yeah. Yeah, this is a right triangle. So you have to use a property of the right triangle. Since there are already lots of the right triangles inside, so it should be made easier, right? You don't need to draw a dashed line here. Can you write down all the possible equations? Okay, let me mark it. Right, all the possible equations. You need you need some equations to you need the equation in x. Then you can get the a and b. Okay, express x in b. Okay, so that is x. Okay, this should be expressed in terms of a and b. Right? Yeah, let's. I'll give you 1 minute. Try to write down all the possible equations. Okay, you probably have to introduce some variables. Okay. Now, if you introduce variables, that's my hint. Okay, this is called the y. That's called the z. Now you have x, y, z, 3 unknowns, right? X, y, z, 3 unknowns. And can you get 3 equations? Then you try to solve for x. Okay? That's my hint. So sometimes you don't need to draw additional lines, but you still need to introduce additional numbers. Okay, additional variables. Can you write down all the possible equations? Okay, how many right triangles are? 3, right? So you just use 3 right triangle. But you should notice that AD is going to be A plus B, okay? That's a key point, okay? Even that's not much. Then you write down all the possible equations, okay? X squared plus Y squared equals B squared, right? Then X squared plus A squared equals Z squared, right? Then Z squared plus Y squared equals A plus B squared, right? So now you have this. Okay, Z squared plus Y. Yes. Wait a minute. X squared, that's my mistake, the first one. I did not carefully look at it. Okay, so the first one is wrong. Okay, so the first one is X squared plus B squared equals Y squared. Okay, all right, so now it's clear. You have 3 variables, 3 equations. But all you need is just equation X possible, right? So you add them together, add these 2 together. So what you get is X squared plus B squared, X squared plus A squared, right? Which is going to be Y squared plus Z squared, which is going to be A plus B squared. Okay. Right. So now you multiply this out. You get 2x squared plus A squared plus B squared. And the other side is A squared plus B squared plus A to AB. Right. So this cancels out. Okay. This is canceled out. So what they do is x squared equals AB. X equals square root AB. Okay. So you don't need to know is the exact value of A and B. All you needed to know is the product. So the product gives you, the product gives you, the square root product gives you as A. Okay. So we discover some formulas, very important formulas. Okay. So that means if you have a rectangle, okay, and this is a right triangle, and this is A, this is a B, right? And then this must square root A and B, and it's interesting. Yeah, it is interesting. The product AB gives you as a side, right? Right? Yeah, I did not know that until I derived this formula. And sometimes it's a surprise, right? As long as the product does not change, the width of the rectangle would be the same, okay? Okay, so that's a good problem, right? I made it. Right. So now, is there any other quick way to solve that without using Pythagorean theory? I think it's possible because many of these triangles are similar. Okay, if this side, let's try another way to solve. I prefer this. There are 2 different ways to do. So this is x, right? So this angle is alpha and that angle is beta. Then this angle is beta, this can be alpha, this is alpha, that's a beta. So you have 3 triangles similar. Okay, if this triangle, 3 triangles similar, and this is x. Okay, then those 2 triangles are similar. Similar means the ratio of the corresponding side will be the same. So x over b equals a over x. Clear? So these 2 sides are same. Let me mark it, the color. This side corresponding to this side, right? And this side corresponding to that side. Okay, those are the 2 triangles we are going to compare. We compare those 2 triangles. Yeah, we compare these two triangles. They're similar. So that's even much quick way without using Pythagorean theory. So x squared equals AB, that implies x equals square A. Right? Oh yeah. See, so this is how do we do that, right? Right. So now here's a similar. Here's another problem. I want to have a rectangle again. Right. Inside this rectangle, I get the right triangle. Okay, right triangle. Good. Okay, this is A, B, C, D, and E. Okay. So I know AE is this side is A. I know AD is B. Okay. It's a right triangle. Okay. Find the area of the rectangle. Okay. So I'm going to put this one B. I'm not going to use it. It's slightly different. Yeah. Okay. Okay. So this right triangle basically is uniquely determined because we know the two sides. Doesn't matter which two sides are given, right? Be clear. Okay. Find the area of the rectangle. Okay. And express it in terms of A and B. Okay. We're going to find a formula. Okay. Please, maybe you can find it two different ways to do it, right? I'll give you some time. So in order to find the area, right, what do you have to do? You have to find, this is x, that's this y. So area is going to be x times y, right? So you have to express x and y in terms of AB. All right, so let's try, okay? Now we're trying to get an x and y, but clearly x is easy, right? X is square a square plus b square, no problem. Okay, that by Pythagorean theorem. Now how to get a y? You can use similarity maybe. Okay, this is y, and all right, here's a and here's b. Okay. We don't know yet, right? How do you do that? Express. Yeah, I think this is we can use a similarity. Okay, this side is a square plus b square, right? Okay, those two triangles similar. I want to, here's alpha, that is beta, okay? Now this is alpha, then this is beta, then this is alpha. So now you have two similar triangles. Compare those two triangles, right? So we come by comparison. A is corresponding to y, okay? Right? B corresponding to this two sides, okay? So let's say y over a should be equal to b over square root, okay? By the similarity of triangle, okay? You compare those two triangles, but you have to find the corresponding side. This triangle, right? And there's the other triangle. These two triangles are similar, but you needed to find the corresponding side. So y corresponding A and the B corresponding to, this is a hypotenuse, right? Then you get y has AB square over A square plus B square. So once you get a y, can get an x, right? And yeah, you already have x. That's interesting. So A is going to be x times y. X is a square of x square plus b square. And here's AB. And that's equal to A times B. Okay? Now, honestly, there's a quick way to do that. Okay? Why? We solve the problem. Okay, no problem. Okay, so what is the second method? You can quickly get this answer. Okay, this is x, this is y. And this is A, B, C, D. Okay, the triangle has height y, right? So the area of the triangle ABCDE, right? So AED is going to be half of x times y, right? But half of times A, if this is A and this is a B. But you can look at the triangle in two different ways. It's also half of AB, right? Yeah. Then you get x times y because A times B, which is the area of it. That's a much easier, quick way. Okay, that's much easier, quick way to solve the problem. Okay, this is the area of the rectangle. You see? So many problems I give two different methods to solve. Yeah, so this is the easy way to solve. Okay, without using Pythagorean theory at all. You don't need it. Just area triangle formula. Okay. All right, so now I'm going to ask you to work on the next problem. I hope you can figure it out within given time. Okay, this is A, B, C, D. This is a square. Okay, unit square. That means each side is 1. Okay, E is the middle point. Okay, this is a middle point. Okay, on the edge. And I draw a line. This is F and the C. So what I'm trying to do is EF equals FC. So this is X, that is X. Okay, it's the same. And I wanted to find the area of the shaded region. Okay, it's this triangle. Find the area of the triangle EFC. Okay. Now I don't. I can assume that this is a rectangle. It's the same. As long as you know the idea, you can always get the answer. Okay. So I changed the unit to square to a rectangle with edge length A and B. So you should be able to determine the area. Okay, so take a look at this. How do you find the area? I think all you need is to find x. Why? Because the height of the triangle is 1/2. Okay, so this is going to be 1/2. So base is x, and the height of the triangle is, this is the height. Okay, this is h. H is going to be 1/2, so it's going to be x over 4. All you have to do is find x. Okay, so I'm going to give you a minute, 1 minute, okay, to think about. And there's any right triangle there? Yes. And you can maybe try to get a new right triangle or using the existing right triangle. And then you write down the equation in x and you solve it, okay? Now you just need to find the x. Right, this h is 1/2, you know, this is middle point. Anyone get the equation? So right triangle is already there. You just look at, this is the right triangle, okay? And you don't need to get an additional one. So let's find out. Let's find out each edge length, okay? So this side is x, right? Yeah, let's mark colored so it's, you know where it's from. Okay. So this is F, that's E, that's a B. So this side is 1/2, clear, right? It's middle point. So how about the other side? Can I express in terms of x? The answer is yes. BC is a unit, has 1, right? So it's 1 minus x, that's all you need, okay? So if it's a rectangle, then it will be like a b minus x and half of a, you know, the other side, okay? So so then you get the equation 1/2 square plus 1 minus x square equals x square, and then the quarter plus 1 minus 2x plus x equals x square. X square is cancelled out. And then I get 2x equals a quarter plus 1, which is 5/4. X equals 5/8. Okay. Now, if I change the problem a little bit, I ask you to, here's A. That's a B, right? And this is a middle point. And then I want to make sure this is X, right? So find X. And then this will be half of A. This will be B minus A. So you will get a slightly more general formula. Okay, you will get a slightly more general formula. Okay, so you, Eric, you said 32. Did I make mistakes? Oh, yeah. No? 5 of 8. Oh, yeah, areas. Yes. I just found X. Yes, that's right. Good. Okay. So here you see, you get a similar formula, half of A squared and plus B minus X squared equals X squared. And you will get equation, linear equation. Okay. And this is X squared equals X squared and canceled out, right? Then X is going to be 2B A squared over 4 plus B squared. Okay. And again, it's 8B A squared plus 4B squared. Okay, so you get another, general formula. All right, good. All right, here's another type of problems, similar. Okay, so we have a rectangle. I find out. So this is A, B, C, D. I take the point E. It's not necessarily middle point. Okay, take another point F. I connect it. Okay, so then I connect this side, connect this side. All right. So what do we give it? Okay, oh, yeah. So we are given the following information. These two triangles are congruent. The triangle EBC, okay, is congruent to the triangle EFC, okay? Those are two triangles. How do you do that? You fold this paper from fold this paper so the point B, touches point F. Okay. I also know that this is a A, that's a B. So AE, I measure that, and AF equals B. Okay. I want to find the dimensions of the rectangle ABCD. Okay. So in other words, I want to find X and I want to find Y. Okay, X equals what? Y equals what, if possible. Okay. All right, so you should take a look at it. So those two triangles are congruent. Okay, those two triangles are same. So that means this angle is the same angle, right? And this is the right angle. This is the right angle. This is alpha. This is alpha. So those two are congruent triangles. All right, you want to, based on the small triangles information, you want to determine the size of the rectangle. That's all I want. Okay. So you have to compute, express X and Y in terms of A and B. Okay. Please work on this. Okay. All right, so let's try this. Let's try trying to set up some equations. Okay. Well, there are many right triangles there, right? So let's express each side in terms of x and y. Then you apply the Pythagorean theory. I probably have to put the one. This one is called z because that's additional, right? And this side is y. And how about the other side? This side is x minus a, so this is x minus a. So and this is a y minus b minus y, right? Okay. So now you have many equations. Okay, let's try this. Okay, x squared plus b minus y squared equals y squared. Okay, that's the first equation. We apply the Pythagorean theorem to this triangle. And another one is x minus a squared plus y squared equals z squared. We apply this. There is also other one is a squared plus b squared equals x minus a, right? And you will see that you probably don't need the third one as the second equation. Okay, this is the only place z shows up. But at least those two equations give you the answer. Okay, because look at the last equation: a squared plus b squared equals x squared minus 2x plus. No, that's too complicated, right? You don't need to multiply this out. All you need is you solve for x minus a. That's a square of a squared plus b squared. Okay, and then x is going to be a plus a squared plus b squared. Okay, so that is x. Yeah, that is x. So once you get x, then you can get y squared. There's the last equation here. You see, this is a first equation, third equation. So by the third equation, you get this. By the first equation, you will get x squared plus b squared minus 2by plus y squared here. Okay, so y squared is gone. So you get 2by equals x squared plus b squared. And then you just divide by 2b. Now, what is x? X squared, we already find x. So x squared just a plus a squared plus b squared and the square. Okay, so now you get express a and x and y in terms of a and b. Yeah, so yeah, it's good. And Erica got, yeah, the formula for the x. All right, so this is what we get. Okay, so just the idea is very simple. Just express each side in terms of the unknowns and the given data before you apply the Pythagorean theorem. Then apply the Pythagorean theory, then you solve the problem. Okay, let's do one more problem. I hope this time I'm not going to forward the paper. I draw the line here. Okay, I get the right triangle. Okay, this is a, that's a b. Okay, and this is a square. We just assume it's a square, so it's already fixed. Okay, it's a square. Okay, so I want to find the area of the square. Find the area of the square. Okay, so in other words, you need to find the x and the x, which is going to be x squared. Okay, can you find the equation in x by applying the Pythagorean theory, and then you solve the problem. Okay, let's try to get some equations, right? So let's look at this picture now. Is there any right triangle there? I have 3 or maybe more than that, right? So this side is, let's say this side is like x minus a, right? This side x minus a. Here's x, and this is a z, okay? Okay, so what I'm going to do, so this side will be x minus b. Okay, so I'm going to call it the u and the v and the z, right? So there are many formula, how many right triangles? Actually, I have a 1, 2, 3, 4 there. Okay, so let's write down a formula one by one. A squared plus b squared is u squared. X minus b squared plus x squared is going to be v squared, right? And I also have x minus a squared plus s squared equals z squared. But the triangle here inside is also is a right triangle. Okay, we use this to get a relationship among those three quantities. So u squared is a squared plus b squared. B squared is x minus b squared x squared. And the z squared is to be x minus a squared plus x squared. Okay, right? So now, right? So now you can get rid of x squared, right? You will get a squared plus b squared. Here's x squared minus 2bx plus b squared. Here's x squared minus 2x plus a squared. So I have x squared canceled out. I also have a squared x squared canceled out, right? What I have here is b squared. I have a 2b minus ax. I hope this is the right answer, okay? Yes. So x is going to be, okay, x is going to be b squared over 2b minus a. Okay. Okay. So that is now this is under condition b is not equal to a, and if b equals a, I don't think you will get a right triangle. Okay. And if b equals a is no solution, okay, that means you're not able to find it. Okay, because the right hand side is going to be 0, left hand side is b squared, so you never get such pictures here. Okay, so this is our solution. Yeah, if a equals b, and you know why? Let me explain to you why a cannot be equal to b. Look at this. This is square, right? If a equals b, and then you and connect them, this becomes isosceles triangle. If it's isosceles triangle, this side equal that side, this alpha never equal to 90 degrees. You never get it. Okay, so a cannot be equal to b. That's clear. Otherwise, it's actually b should be larger than a. Okay, so this is not 90 degree. If it's 90 degree, and this b must be greater than a. Okay, so b must be greater than a. Okay, and then you can make it the right triangle like this. Okay, so b must be greater than a. That's why so b minus a is a positive number, so you never have a problem. But on the left hand side, you have a 2b squared. Oh, yeah, that's a 2b squared. That's right. That's right. Yeah, that's my mistake. So 2 canceled out. Yes. You're right. It's easy to make mistakes. Yeah, I missed the 2 here. All right, so our last problem, maybe the last problem, okay? And we're talking about isosceles triangle. This is an isosceles triangle. It's an isosceles triangle. So we know the parameter equals 64. Okay. The height equals 8. Find the area. Okay, so this is a parameter here, this is 8. Okay. Okay, so this side is A, this side is A, this is a B. We are given A plus B, 2A plus B equals 64. What we want to find out is we want to find the area. Area is half of the B times 8, which is 4B. So in other words, you needed to find the B. If you know the parameter of an isosceles triangle. Is there any way you can do it? All right. Any idea? Well, you see the right triangle there, right? You see the right triangle there. So just apply the Pythagorean theorem. Right triangle, right? This is A, that's A, this is a half of B. Okay, and you have two equations. One equation, 2A plus B equals 64. Another equation is A squared plus B over 2 squared equals A squared. Okay, so you want to find the B, right? Find the B. Then you can do that because of two equations, two variables. In general, you can find the B. Okay, so replace A by, this is the first equation, second equation. By the first equation, A is going to be 64 minus B divided by 2. Okay, so it's a 32 minus half of B. So I'm going to put into put it into here, right? Then I square this equation in half of B, right? So it's going to be 32 squared minus twice of 32 times half of B and half of B squared. So now half of B canceled out, right? And then I got this canceled out. I got 32B equals 32 squared minus X squared. All right. Now I don't want to multiply them out. 32 is 4 times 32, 4 times 8, right? 32. So that will be 4 squared, A squared minus A squared, right? Right? So you get 16 minus also 15 times a squared. 16 minus 1, right? So b is going to be 15 times 8 squared and 32. And now I can simplify a little bit. It's 15, 8 squared, 4 times 8. So I can say 1, 4. Then I divide by half. 8 divided by 4 is 2, so it's 30. So 30 is going to be the base. Okay. Once you get the base, then you get the area. Okay. So area is, it's already there, right? It's a formula is A equals 4 times B. So area is 4 times B. It's 120. Okay. So we discussed so many problems. Sometimes we have to draw additional lines to get right a triangle, right? Then you try to express each term in terms of some unknowns. Now, maybe you have to introduce additional variable, okay? So in that case, you have 2 or 3 right triangles. You apply the Pythagorean theory to all of those right triangles. You have 3 unknowns, you should have 3 right triangles. Then you try to eliminate some variables and find what you want. Clear? Yeah. Now, in some special cases, you probably have a shortcut without using Pythagorean theory, is the similarity of triangles. And you can get the answer quickly. That's like the problems we discussed at the very beginning. Okay, I think it's fun in geometry. It's fun, Yeah, you have to solve them using algebra, but at the very beginning, you still needed to draw addition lines if possible. It's sometimes necessary. Yeah, then introduce variables. Okay, and even it's not given. Like this isosceles triangle. So what you should do, right? You have to name the variable a and b, right? And each side, then you should get 3 equations. 2 variables should get 2 equations. Right, that's all about today's class. I'm going to send you the homework, and I hope you will do well. Right.